Welcome, my name is Tom Faller. I'm with the Georgia Mineral Society, and today we'll be talking about common rocks and minerals that you can find locally and showing some interesting facts about them. Then I'll discuss how they can become gemstones and other precious rocks or stones. First, I'd like to answer an important question. Aren't minerals rocks? Well, they're not people or birds or plants, so yes, they are. But minerals have important characteristics that make them different from rocks. For instance, rocks are made of minerals. Minerals are something solid. Ice is a mineral, but water is not until it turns to ice. Being solid, it has a regular chemical structure that defines what it looks like and how it behaves. This structure is called a crystal. And crystals come in several shapes. Not all crystals look alike, and the shape of a crystal can tell you things about what the mineral is. So rocks are made of minerals, and you can sometimes see the mineral crystals in a rock, and that tells you what kind of rock it is. It also tells you something about the history of the rock, because minerals form at different temperatures and pressures, and can be subject to strain soon after they form. We'll see some examples of this soon. A mineral also has certain properties that set it apart from any other mineral. I've already mentioned the crystal form, which follows from the elements that make up a mineral. Those elements also affect things like the color and the density of a mineral. And if the mineral is transparent, it affects how much it bends light. Another property is hardness. Talc, which you find in talcum powder, is one of the softest minerals. You can scratch it with a fingernail. Quartz is a lot harder. You cannot scratch it with a knife, but you can scratch quartz with sapphire. And you can scratch sapphire with diamond. And diamond is the hardest mineral and can scratch all other minerals. Some elements can be minerals by themselves. Gold, for instance, and silver can be found by themselves. Other elements like silicon and aluminum bond so easily to other elements that they're almost never found in nature by themselves. So minerals are groups of elements, and rocks are groups of minerals that are commonly found together. Some rocks, like granites, are made up entirely of crystals. Crystals throughout. Some, like obsidian, have no crystals. They cool so quickly that crystals can't even form. Some rocks, like sandstone, are made up of the ground-up pieces of other rocks. And some, like limestone, are made up of the bodies and ground-up pieces of sea-dwelling animals and creatures. So every seashell eventually ends up as a limestone. And if all this wasn't enough, pieces of the Earth's surface move around and over time will bury and heat and pressurize rocks so that the minerals change and they might stretch out and they might even become other minerals. We'll see examples of this around Atlanta. So let's start with the basics again. Quartz is a mineral. It's formed with two elements, silicon and oxygen. Neither one that looks like quartz. This is silicon. It's artificially man-made, and it's eventually going to be part of an electronic circuit. Oxygen is in the air. You can grab some on your side if you want. Put them together, they come up with something that doesn't look like either one. Quartz can be combined with feldspar. Feldspars come in very different colors. This one is brown and gray and white, but they also come in blue-green and kind of a pink and other colors, depending on the amount of trace elements in them. You combine quartz and feldspar and mica, which is another aluminum silicate element, kind of like feldspar, and you get granite. And granite is all over Georgia. This particular sample is from Elberton, Georgia, and it's mined out because it's nice and even in texture. You can see, if you look real close, the little transparent pieces of quartz, the gray and white pieces of the feldspar, and the tiny black specks, which are the mica. But we also have other mines that make granite around Elberton. This is from a mine that's fairly close. Notice the difference in the grain sizes. This one was allowed to cool for a few more million years than this one. So if you cool the rock more slowly, it gets bigger crystals. That's something interesting to think about when you think about something with crystals this size. So, if granites get reheated after they're formed, the minerals in them can flow and even become other minerals. This is an example of what was probably a granite one time, and you can see all the dark minerals are now flowing in a pattern. This sample is from Arabia Mountain, and you can see the dark little minerals here are actually now something completely different. Instead of mica, they've turned to tourmaline, tourmaline being a precious gem. If you're walking around on Arabia Mountain or on Stone Mountain, you'll see places where the rock has flowed and stretched, and you'll see little spots where tourmaline crystals pop up on the mountainside. They're called cat's paws by the locals, and you'll see them if you take a walk around either park. If a body of molten rock cools more quickly than granite and keeps some of its heavy elements like iron or manganese, it becomes a rock that we call basalt. Today we see basalts around volcanoes and around the ocean floor and in places where magma is intruded from very deep in the earth up through cracks that run close to the surface. Basalts can get reheated as well as granites, and you'll see some of those around Atlanta as well. Rocks don't last forever. Over time, wind and water will gradually break into the rock, forming cracks, and eventually dislodging some of the minerals and dissolving others of them. Quartz, for instance, gets broken down, and as it's dislodged from the rock, it gets loose. It becomes little crystals that start flowing along with water, knocking into each other, gradually getting rounded off and smaller, and becomes sand. And the sand eventually piles up and becomes sandstone. Micas and feldspars eventually both get dissolved and become clay. And the iron in these minerals comes out and becomes the red tint to Georgia clays and sandstones. The clay eventually washes down rivers into the ocean and becomes shale when it hardens. Other rocks we have, like limestones, get deposited on the shales, the sandstones. Eventually these become a whole group of rocks that at some point will get lifted up again, become mountains maybe, and then get eroded again. So, all this is very interesting and is useful, but you're asking yourself, when do we get to the good stuff? And the good stuff is gemstones and precious stones. So first, where do gemstones come from? They are minerals in their best crystalline form. with deep color, good transparency, and it means a very regular crystal structure and very few unwanted impurities. Light has to be able to shine through a gemstone clearly in order for it to be worth anything. If you can't see through it, it's not a gemstone. So, take a common mineral like olivine, which shows up in basalts a lot. Olivine was called that for its olive color. Bury it deep, subject it to very slow heat, let it cool very slowly, keep it away from anything else, and you eventually get a gemstone called Peridot. Peridots are nice and transparent and pretty, and these can be used as beads or cut into faceted stones as gems. Those are some peridots that I tumbled, and I think I'm going to use them in some sort of project. Other gems, even rubies and emeralds, have very dull and uninteresting forms as well. So the ones that are nice, clear, transparent, deep color are very rare. There are some varieties of inexpensive gemstones which I have, and I'll show you the range of color and cut, how they cut gemstones to bring out the interesting properties. Originally, most precious stones weren't faceted or cut at all. They were just polished. If you look at crowns of the kings of Europe and Asia, most of the stones in their crowns look round. They're large and impressive still, but they aren't anywhere near the degree of detail that modern crowns have. So at first, people put a few cuts making a round looking stone or a square one, but gradually the actual form of what you'd call modern cuts, which reveal the most amount of light in a particular stone, were developed. So we have some round stones here. This is kind of a square cut. There's a pear-shaped cut. And then we have various degrees of oval cut to show off the stone as best possible. The square cut here is called an emerald cut because it brings out the best qualities of an emerald. Now the color of stones is always very interesting. It depends on some of the minerals that are involved in that particular stone, and chromium in a mineral usually gives a green stone. Light blue is usually caused by iron, as is purple. Iron and manganese might make a brown stone, or even a light yellow. And of course the clear stones, diamond, white sapphire, white topaz, usually mean that there are no impurities or coloring agents present. Finally, we have these little triangle-shaped stones, which are a fairly modern cut. And those are for very specialized kinds of jewelry. Well, gemstones make the case that minerals are cool, but what about rocks? Are they only for driveways and tombstones? Remember when I said that remelting rocks can cause new minerals to be formed? You can find a lot of rocks locally where this happens. And if you decide to take a rock, cut it into a little slab, and then mark out the shape that you want, cut that and polish it, you end up with precious stones that can be used in a variety of jewelry, and they're just as interesting as gemstones. And they're a lot easier to find and to deal with. They can make all sorts of jewelry and decorative products. I hope that you've enjoyed this presentation, but you just scratched the surface of rocks and minerals. Thank you.